my name is Jigar Shah. I'm a product manager at Palo Alto Networks focused in public cloud security. Today I'm going to talk about how application and security teams can work together for scale-out architectures in Azure. Application teams would like to manage and operate the public cloud environment with full flexibility and deploying things as they need, while security teams would like to maintain good security best practices, and that means having visibility in the traffic, ensuring consistent security in the public cloud environment as their on-prem data centers, and having more automation and scale-out architectures that allow you to deal with scale. So some of these goals have a slight conflict in that app teams want to go fast, while security teams want to make sure all these consistent capabilities are built out in the public cloud environments as well. To deal with this, the cloud architectures have now evolved and matured enough to offer an ability to build these in Azure consistently now. So now let's look at how you can do scale-out security for inbound traffic into Azure. So we start with a typical external-facing load balancer. You have a deployment of VM series firewalls behind it. An internal load balancer that front ends the application stack. So this is a classic load balancer sandwich architecture in Azure. The external load balancer front ends the traffic. All the application traffic from the outside world comes in here. It gets load balanced across a set of VM series firewalls that apply the security policy that you've configured. And then after inspection, traffic is sent over to the internal load balancer that front ends your application's web tier, or whatever the front end is. This gives you an ability where as traffic surges, this load balancer is going to be automatically scaling itself to deal with your load. And the firewall tier can be added or removed in terms of adding more capacity, and that also gives you more availability. Similarly, your web tier is going to also scale behind the internal load balancer. So this is a typical scale-out architecture for inbound traffic. So what I'm going to show you now is how to do outbound and east-west scale-out architectures in Azure. So what we have here is an architecture for scale-out of outbound and east-west security. Outbound flows meaning traffic that go from your application tier to the internet or to the on-prem environment. And east-west flows mean traffic that flows between different VNets or between different subnets inside a VNet, or even potentially between different VMs inside a subnet, right? So this architecture is set up where each of these subnets for the web tier, the application tier, and the database tier are using the Azure user-defined routing, the UDR feature, to point to the Azure Load Balancer. So this is the Azure internal load balancer with a virtual IP address, the VIP over here, where all the traffic is redirected. And behind this load balancer, we have a set of firewalls that are inspecting that traffic that comes from over here. So this is a unique capability in public cloud environments where you can completely redirect traffic to an internal load balancer, and then you can scale out security behind it. So here's how the traffic flow works. When packets leave the web tier and they're supposed to go to the application tier, they will show up at the load balancer. They will get load balance across the firewalls, and the firewalls will apply the security policy. For example, you may say web goes to database, allow only MySQL traffic. Exactly what your policy is intended, the firewall will inspect it, and then the traffic will go to the load balancer and back to the database tier. What this gives you that capability that this firewall tier can scale out and scale in as you desire based on their load requirements. Now, the load balancer offers a couple of unique capabilities to make this much easier in terms of the deployment. The first thing I mentioned was UDR, user-defined routing, to the internal load balancer. The second thing is this Azure Load Balancer now offers the ability for what is called as floating IP mode. What that means is that the load balancer does not do a destination NAT to the firewall for the load balancing of traffic. What that actually means is that the firewall actually sees the actual destination IP of the packet. So in practical terms, what it means is web server going to database, firewall sees the destination as a database. If policy allows it, it lets it go to the database. So that's the east-west flow I mentioned. Similarly, let's say the web server is trying to go out to the internet. For example, if you have an Ubuntu server and you wanted to go get apt-get software updates from ubuntu.com, when the packet comes over to the firewall, it's actually able to see the destination. And if the security policy allows that, oh yes, you can do apt-get, fine, an Ubuntu server can go get updates. So this protects you from exfiltration of data in terms of your application tiers being well protected. Now, one more variation or capability on the Azure Load Balancer is the capability that it now supports HA ports. This is a new feature that is available in the standard CDs of the Azure Load Balancer. What HA ports means is that the load balancer can load balance across any port and protocol. Now this is really crucially useful in operational terms. For outbound flows, you usually know the ports. Usually it's HTTPS or a few specific ports. But especially when you're going from web tier to application tier to database or to an AD server or other servers, there's lots of ports that get used. So normally, when you redirect all that traffic to the load balancer, you would have to configure all those ports that the load balancer needs to load balance on, and it needs to do health probes on. The capability of HA ports allows you to just directly point all the traffic using the UDR capability, and when HA ports is turned on, all traffic gets load balanced automatically for you. And that means that firewall can now scalably apply the security policy as you intended to do. So what this gives you a capability for is that the application and operations teams can build what they like in terms of the VNet and the subnet architecture and deploy their VMs as they'd like. And security teams can use the Azure Load Balancer and the UDR capabilities to completely go and secure it without interrupting the design of the applications team. What I'm going to show you next is an evolution of this design on how this can be used at a larger scale across the organization. And this is an architecture we like to call transit or hub and spoke. So you can imagine the central stack of VNet that is for the firewalls. This is the hub. You have the load balancer like I showed you earlier. You have a set of firewalls, and then you may have an internal load balancer. This is the hub. What you can now do is you can have several VNets that are acting as the spokes. And this could have several applications or a single application. Similarly, you have spoke number 2, where app number 2 can reside. These VNets may be peered so that they have direct connectivity. What you end up doing is that there is UDR set up in each of these VNets that redirects traffic to the load balancer in this VNet, and behind which are firewalls. This VNet then essentially becomes the central or the shared VNet through which all security is inspected and sent along its way to the destination. So when traffic is going from one VNet to the second VNet, the UDR rules force all the traffic to go through the firewall hub, and after inspection it goes to the destination. Similarly, when traffic is going from the application tier to the internet, the UDR forces all traffic through the firewall tier, and then it can go to its destination, the internet, or in exactly the same way, when traffic from this application needs to go to the on-prem environment, the UDR forces traffic through the firewall tier, and then it uses the normal connection that you have got, either an IPsec or an express out, to go back to your corporate network. So this gives you sort of a higher out, scale out architecture where the firewall tier becomes sort of the hub, call it the large distributed firewall in the cloud that secures different applications when they need to talk to each other. So let me walk you through all the things and architectures we walked through in this discussion. First is that the firewall tiers are in the traffic flow, and so you're able to get visibility. What you're able to do next is that the same firewall, VM series, is running PAN-OS, same as your hardware firewalls on-prem, providing you that same consistent security across all environments. And this makes it much easier to apply consistent policies in all environments. So we talked about visibility and consistent security. And for scale out, you're able to use the Azure Load Balancers and the UDR capability pointing to the internal load balancer, the HA ports, and floating IP features. All this give you a great scale-out capability. But what about automation? Well, you can use several capabilities available in our GitHub repo or on our website for ARM templates, Terraform templates, along with Ansible, or you can use the native bootstrapping capabilities of VM series to fully deploy a completely configured firewall. And that gives you that automation and scale-out capability combined with visibility and consistent security all across the board. So in summary, the application teams and security teams can work together without sort of compromising in either team's objectives, which is fast and consistent deployments in Azure and still completely secure. Thank you.